Okay, now we move on to section 6.3, which is dealing with triangles being similar. Now, in chapter 4, you dealt with proving triangles were congruent. And remember, you had 5 different ways to prove triangles congruent. You had side, side, side. You had side, angle, side. You had angle, angle, side. You had hypotenuse, leg. And you had angle, angle, angle. Now, these 5 are very similar in that you use different parts of the triangles. The only one that we will not be using again is hypotenuse, leg, and specifically because that deals with right triangles. What we're moving into is not necessarily proving triangles are congruent or proving that they are similar. Remember, similar means proportional. And in this specific section, we're going to prove that triangles are similar or proportional just by proving two angles, of those two triangles are congruent. Now, if you notice, in the AAS and AAA congruencies, you have 2 angles that are congruent. And those 2 are the ones that we're going to use. The angle-angle side congruency and the angle-angle similarity postulates are similar, baby. And if you can imagine that in the Austin Power voice, it'll be a lot more impactful. In fact, you'll actually remember it better. In postulate 22, it deals with the angle-angle similarity postulate, where if 2 angles of one triangle are congruent, remember, the sides are proportional, but the angles have to actually be congruent, of 2 angles of another triangle, then the 2 triangles are similar. Now, you can actually move the triangles on top of each other and see that they're congruent, or you can set up addition statements. We all know that the inside of a triangle has to add up to 180. So if you take this specific example, we can say that angle K plus angle J plus angle L equals 180 degrees. We also know in the other triangle that angle Y plus angle X plus angle Z equal 180. Now we know that K and Y are congruent, so we can actually cross those off because they equal each other. J and X are also congruent, we can see that, so we can cross those off. Now what we get is that these 2 angles, the angles that are left, have to be congruent to each other. Why? Because all 3 angles have to add up to 180. So if angle K and Y were, let's say, 145 apiece, and let's say that angle J and X were, let's say, 20 apiece, we'd still have one more angle that has to get us to 180. And only one angle, well, if this adds up to 165, this angle has to be 15. If this adds up to 165, this angle has to be 15. Only one number can be the supplement of those 2 other angles. So you'll notice that because the other 2 are congruent, the third ones have to be congruent. It's just the way addition works. They have to add up to 180 degrees, therefore they have to be congruent. And this is dealing with AA similarity. Being able to prove that 2 angles are congruent means that you have 2 similar shapes. If we move on, if you look at these 2 triangles, we're told to determine if the 2 triangles are similar, and if they are, to write a similarity statement. Now you look at these 2 triangles. Although they're not in the exact same position, we do know that one of the angles in each are congruent. Can you tell which one it is? Hopefully you notice that this angle and this angle are both congruent. Why are they congruent? Because they're both right angles. So we can say that angle G is congruent to angle D. You'll notice I'm going from the larger to the smaller. Angle G and angle D are congruent. How? Because they're right angles. How do you know right angles are congruent? Well, because right angles equal 90 degrees equal other 90 degrees, therefore they're congruent. But then let's look at the other ones. 26 and 64 are the 2 other angles that they give us. But 26 and 64 are congruent. So what we need to do is look at the other angles they haven't given us. They did not give us angle E. They did not give us angle K. So let's actually solve for those missing angles. I know that in this triangle, 26 plus 90 has to equal 180. Or 26 plus 90 plus angle E has to equal 180. And in this triangle, 64 plus 90 plus angle K has to equal 180. So what I'm going to do is set up a couple problems. 26 plus 90 plus E equals 180. 64 plus 90 plus k equals 180. And I'm actually going to solve for e and k. If I add up 126 and 90, I get 116. And then if I subtract 116 from both, I get e equals 64. And then I'm going to solve for k very quickly, but hopefully you noticed something already. 64 and 90 is 154 plus k equals 180. Now if I subtract 154 from both sides, I get k equals 26. Now I hope you noticed something very interesting. I hope you noticed that angle E is 64 degrees, and that is actually congruent to angle H. Maybe you solved for k already, but you should still notice k is congruent to angle C because it's 26 degrees. So now, in order to prove these two triangles are similar, we already have one angle congruent to another angle. I can say that angle E is congruent to angle H, or maybe you used angle K being congruent to angle C. Either way, you have to be able to prove that two angles are congruent before you can say the two triangles are similar by AA. And when you prove the two triangles are similar, you have to be able to say that, like HGK is similar to triangle EDC, and by AA similarity. Now the other problem is not as easy. The other problem deals with parallel lines, and this takes us back even further into our geometry year. But when you have two parallel lines and they are cut by a transversal, let me highlight it just so you can see it. Maybe that'll help you remember. If you have two parallel lines that are cut by a transversal, you have special angles that are formed. Do you recognize the letter this forms? Hopefully you're saying to yourself that forms a Z. And I remember that when I have a Z and parallel lines, I have alternate interior angles. And when two lines are parallel, cut by a transversal, alternate interior angles are congruent, meaning angle S is congruent to angle U. Why? Because of alternate interior angle theorems. I can also do the same thing for R and T. Because I have RS and UT being cut by a transversal because they're parallel and cut by a transversal, I have alternate interior angles being congruent. I have angle R congruent to angle T by the exact same reason. Alternate interior angles are congruent. Some of you are saying, well, I have a third angle that's congruent. I have angle V congruent to itself because it's a vertical angle. You could also say that SVR is congruent to UVT by vertical angles. Either way, you'll notice that before you can prove the two triangles are similar by AA, you have to first prove which two angles you're dealing with. Now, in the first example, or in the first part of example 1, we proved two angles were congruent. Once we proved two angles were congruent, then we can say the two triangles are similar. In the next example, you could use S and U, R and T. Well, those are two angles. Once you've proven two angles are congruent, then you can say the two triangles are similar by AA similarity. And it doesn't matter to me which angles you use as long as you use two angles. Notice AA, angle, you have to prove two angles are congruent before you can say the triangles are similar. Now, tonight's homework, you're just going to be dealing with AA, just with angle similarity. So look at these two examples again if you need to. But specifically, chapter 4 dealing with angle congruencies, those are really going to play a big part. Maybe you have to solve for some missing angles like we did in the first one. You might have to do a little bit more algebra to solve tonight's homework problems. But the geometry involved is only going to be proving angle similarity. So let's go ahead and look at your homework now.